Swayam Prabha. Digital India. Educated India.
We finally begin the discussion that we have been promising from the beginning of this course. We talk about the first atom, the atom, hydrogen atom, where Schrodinger equation can be solved, can be solved, let us just say that, let us not say easily. So, I hope all of us are as happy as this pretty little nucleus here. We have got the cartoon from this website, and the reason why I put it here is to remind ourselves that okay, in all this discussion of quantum mechanics that we have done, we said at the very beginning that Rutherford model had shortcomings, but the experiment was right. The experiment performed by Rutherford students Marsden, you might remember we had talked about it in the very first module. That experimental result was not wrong. It said that almost all the mass and all the positive charge of the atom is centralized on this big fat, and in this cartoon happy nucleus, and the electron goes around it. Now, the only thing that we have shed from there is that the electron goes around in circles, or the electron goes around in ellipses, or we have shed any pretense of being able to say what kind of trajectory the electron has in the atom, that we cannot say, right. But the essential model is that you have a heavy nucleus at the center, and in the rest of the atom, which is mostly void, you have our electron, and this electron wave function is obtained by the Schrodinger equation. Okay. That is what we are going to discuss over quite a few modules after this. And in all this discussion, techniques that we have learnt earlier in free particle, particle in a box, tunneling, simple harmonic oscillator, rigid rotor, everything is going to come handy. That is why we discussed all these systems before getting into the first real chemical system, that is hydrogen atom. So, perhaps this is not even required anymore because we have done so much, but just to recapitulate, Schrodinger equation, lest we forget, is really a classical wave equation for de Broglie waves. Essentially it is an eigenvalue equation where you have an operator operating on a wave function to give you back the same wave function multiplied by a constant. This wave function is called an eigenfunction of the operator. The operator we use in Schrodinger equation is Hamiltonian operator, total energy operator. So, the eigenvalue that you get is the value of energy. Expectation value, as we have discussed, is integral psi star a psi d tau divided by integral psi star psi d tau. Well, if psi star is normalized as a well behaved wave function would be, then denominator would be 1 anyway. And most important thing is we have learned that quantization does not fall from the sky, unlike Bohr model. Quantization arises naturally when we use boundary conditions, and we have to use boundary conditions because we are working within the ambit of Born interpretation that these waves are probability waves. Psi star is probability density, right. This is what we need to remember and use as we go from here. Alright. So, the first thing to do is to build the model of hydrogen atom, and the model as we said earlier comes from your Marsden's experiment. There is a nucleus, let us say the coordinates of the nucleus are xn, yn, zn, and there is an electron xc, ye, ze. This dotted circle is you can just neglect it for now. So, it is a 2 particle central force problem. Well, the dotted circle is not completely irrelevant. Why am I calling it a central force problem? Because the electron no matter where the electron is on this circle, the potential energy will be the same. Potential energy is directed towards the center of the circle, okay, the nucleus. So, it is a central force problem, and we will see in a couple of minutes how that greatly influences our choice of coordinate system. Alright. So, we will take baby steps. Let us try to write the Hamiltonian in the simplest possible form. The Hamiltonian of course would have 3 terms. First is the kinetic energy operator for the nucleus, second kinetic energy operator for the electron, and finally the potential energy between the nucleus and the electron. Okay. That is what your Hamiltonian would look like. So, since we know what the kinetic energy operators are, we can expand a little bit. Instead of Tn, we can write minus h cross square by 2mn del n square. So, del n square is the Laplacian for the nucleus. Instead of Te, we can write minus h cross square by 2me del E square, E for electron, minus, well, we do not always do this because it is just a constant, but to keep it in SI unit and we are following Atkins convention here, minus 1 by 4 pi epsilon 0 Zn Zd E square by Ren. Okay. What is Zn? Zn is this capital Z, remember this is not this small z here. Zn is well, Zn E is the nuclear charge, E is the fundamental unit of charge, Zd into E is the electronic charge, of course Z is going to be 1, well minus 1, and Ren is the separation, instantaneous separation between the nucleus and the electron. So, that is the Hamiltonian, okay. And lest we forget, the Laplacians are essentially del 2 del x2 plus del 2 del y2 plus del 2 del z2 with the appropriate subscript nucleus, n for nucleus and E for electron. Great. So, this is what it is. Now, to simplify the notation a little bit, we will write Z instead of Zn, and for Zd we are going to write 1. Okay. So, we will keep this minus charge explicitly, we will not write Zn. If you wrote Z equal to minus 1, this minus charge would have become plus charge, well this minus sign would have become plus sign. So, we will write Z equal to 1, and instead of this 1 by 4 pi epsilon 0 we could have written it 1, but let us just write q for now. So, with this the Hamiltonian becomes minus h cross square by 2mn del n square minus h cross square by 2me del E square minus qz square by Ren. Okay. Now, if this is Hamiltonian, what is Schrodinger equation? H psi equal to E psi. So, let this H operate on psi, well when I write psi total I mean psi of the entire atom, I do not mean the so this is still time independent, okay, not the time dependent part. We got rid of the time dependent part in one of the early modules. We only work with time independent part of the wave function, but psi total means it is a wave function of the entire atom, nucleus as well as electron. Okay. So, this Hamiltonian operating on psi total gives us E total. Once again E total means the total energy of nucleus and electron multiplied by psi total. Okay. So, the psi total I hope is not very difficult to understand, is a function of 6 coordinates xn, yn, zn, xe, ye, ze. It is not enough to specify just the coordinates of electron or just the coordinates of nucleus. You need to know both because you need to understand the interaction between the electron and the nucleus when talking about potential energy. Okay. So, psi total is really a function of 6 coordinates, 2 pairs of xyz coordinates, one for the nucleus, one for the electron. Okay. So, next part I will sort of skim through a little bit, will not really go through all the math. So, first thing we need to do is we need to separate Hamiltonian into the motion of the center of mass and motion of electron with respect to the nucleus. Let us discuss the physics or the philosophy of it. Maths is a little laborious, there is no need to get into that at the moment. So, what you are saying is this: your atom consists of nucleus and an electron. Okay. The electron and nucleus move with respect to each other, 2 body problem, and we know how to reduce it to a 1 body problem by considering reduced mass. Okay. Question here, I have a heavier body and a lighter body. Does the reduced mass resemble or is closer to that of the heavier body or the lighter body? Okay. Please work out. Let us say M1 equal to 1000 and M2 equal to 1. What is reduced mass going to be? Is it going to be 1001? Is it going to be 999 or is it going to be something close to 1? Okay. I leave it to you to figure that out. Okay. When you do it, you will see that it is actually closer to 1. Okay. So, we reduce this 2 body problem. See, it is like the sun and the earth. When we say the earth goes about the sun also goes about the earth. It is just that since earth is much lighter than the sun, the effective mass in the system is like that of the earth. So, approximately we can say that sun is stationary and the earth is going around the sun. Similarly here, the electron is much lighter compared to the nucleus. So, the reduced mass will be close to the mass of electron, and the problem essentially boils down to something with mass that is close to that of the electron going around a stationary nucleus. That is what we are going to arrive at eventually. And the other thing is the entire atom is moving. If you think of, let us say, the earth and sun combined, are they only moving about each other? The entire solar system is moving, the entire galaxy is moving. Yeah. So, that motion has to be separated. Unless we separate, we will have too many terms and we will not be able to solve it. So, we have to separate the Hamiltonian into center of mass and internal coordinate. Remember, it is not enough to do it in terms of nucleus and electron, because internal coordinates has both. You are talking about potential energy. So, you need the coordinates of nucleus as well in addition to that of the electron. Okay. But if you can figure out how the center of mass moves and how electron moves with respect to each other, electron moves with respect to the nucleus, these are 2 separate kinds of motion. We should be able to separate them. Okay. So, let me just show you the definitions and not go through the math. Let us say this is the position of the electron which has mass me, this is for nucleus, this is the center of mass. Let us say this diagram is definitely not to scale. So, this is the position vector of the nucleus Rn, position vector of the electron Re, and you know how they are defined, the position vector of Cm. So, what we do is we define this kind of a system where x is equal to xc minus xn, y equal to ye minus yn, z equal to ze minus zn. What is that? Just think of the x coordinates. So, if this is the x coordinate of the nucleus, this is the x coordinate of the electron, xc minus xn essentially is the separation of the electron and the nucleus in x direction. Ye minus yn is the separation between electron and nucleus in the y direction, same for z. Okay. And this is this separation is the important parameter when you talk about potential energy. This separation is important when you talk about the motion of electron with respect to the nucleus, relative motion, and this r is Ren. So, that is the Re minus Rn, do not forget that the vectors you get when you do the vector addition, vector sum, you get root over x square plus y square plus z square. So, these are the internal coordinates and these are the center of mass coordinates. This is once again very standard techniques of rotational dynamics from classical physics, when you invariably have to separate translation from rotation. Okay. Lots of motions can take place, lots of kinds of motion can take place at the same time, but you have to separate each kind of motion, otherwise you cannot really formulate your problem. So, capital X, capital Y, capital Z denote the position mass weighted position coordinates of the center of mass, and capital R is also for the center of mass. So, what happens is that this Schrodinger equation in terms of electronic and nuclear coordinates can be rewritten in terms of your relative coordinates and center of mass coordinates. Okay. So, what we see is how you do it. I will just browse through the appendix 1. If you are interested in the detail, you can go through it. It is not required for this course. But what is important to see, the reason why we have 2 colors of highlights is that the first term is minus h cross square by 2m, capital M, remember capital M is the total mass of the atom, minus h cross square by 2m del capital R square. So, this would be the kinetic energy term of the center of mass. The second term is minus h cross square by 2 mu. What is mu? The reduced mass multiplied by delta small r square. So, the second term is the kinetic energy term of the electron with respect to the nucleus. I am repeating this so many times because it is important to understand. With respect to the nucleus, I am not talking about motion of electron in the free space coordinate. We are talking about movement of electron with respect to the nucleus. Does the separation with nucleus increase or decrease? Does xc minus xn increase or decrease? Ye minus yn, ze minus zn, what happens to those? That is what we are dealing with. Okay? Please remember, relative coordinate means how the electron is moving or what is the situation of the electron with respect to the nucleus. So, second term gives us the kinetic energy term in Hamiltonian for the motion of electron with respect to the nucleus. Third term minus q z square by r, r remember is the separation between electron and nucleus. So, minus q z square by r obviously is, well, it always has been throughout the discussion, the potential energy for interaction of electron with the nucleus. So, second and third terms together are in relative coordinates and they talk about the motion of movement of electron with respect to the nucleus. The first term in a different colored highlight is for the movement of the center of mass. So, Hamiltonian is nicely separated into 2 parts, one for the center of mass, one for the electron with respect to the nucleus. How? This is how. Okay. So, Hamiltonian is sorted. Hamiltonian can be written as Hn plus He, n for nucleus, E for electron with respect to nucleus. Now, we have to worry about the wave function. What are we trying to do? We are trying to do separation of variables. We are trying to separate the center of mass motion out and forget about it and worry only about the relative motion. To do that, we can conveniently, we have already said this, we can conveniently write this psi total as a product of 2 wave functions, one function in the nuclear coordinates, one function in the electronic coordinates, relative coordinates. This is what we have been doing from the beginning. Whenever we have a complicated situation and whenever we want to break down a more complex equation into smaller, simpler ones. So, now see, minus h cross square by 2m del r square will operate on chi n and psi e is going to be constant as far as it is concerned because it is a different coordinate system. The second one He will operate only on psi e as far as it is concerned, chi n is going to be constant. We have once again encountered it as recently as when we wanted to separate theta and phi for a rigid rotor, remember. So, E total also can be written obviously as E n plus E e. So, what we can do is, I am not going through the steps of separation of variable because we have done it several times. I hope all of you can do it. If not, please post your difficulty on the forum and we will try to address it. Okay. So, the first equation we get, if you look at this highlight here, is H n chi n, that is minus h cross square by 2m del r square operating on chi n, no potential energy. Remember, we are talking about one hydrogen atom, we are not talking about a hydrogen atom that interacts with anything else, that equal to E n chi n, only kinetic energy term is there. So, a system which has only kinetic energy term, no potential energy 0, have you encountered something like that? Yeah, yes we did. That is a free particle. A free particle is something that does not care about anything else in the universe, does not have any potential energy, any interaction with anything else. Okay. So, this is what gives us an idea about how fast the atom as a whole is moving, kinetic energy of the atom. If you go back once again to the sun earth combination, it gives us an idea about how the combine of earth and sun is moving in space, translational motion, and we know the energy, do not we? What will be the energy E n? N means for the center of mass, energy will be h cross k square divided by 2m. This is what we learned when we talked about the free particle, and as we know k can take up any value including 0, yeah, and this is it can take up any value. So, this is essentially for translational motion of the atom as well, atom behaves as free particle. That being said, at the moment we do not care, right, we have talked about free particles, that is done and dusted. We are only interested at the moment in the electronic part of the Hamiltonian. Okay. For the rest of the discussion, this is what we are going to talk about. Electronic Hamiltonian operates on the electronic wave function to give you electronic energy, and this is energy of the electron in the field of hydrogen atom. So, H psi operates on E psi on H e operates on psi e to give you E e multiplied by psi e. This is our hydrogen atom, alright. Now, Cartesian coordinates is what we are most comfortable with. So, we know very well that the Laplacian is written as del 2 del x2 plus del 2 del y2 plus del 2 del z2, and even if we do that, we can perhaps try to write psi e as a product of psi e x, psi e y, psi e z and try to separate the variables. We would have been successful in doing it if the second term was not there. The second term is qz is minus qz square by r, and r is square root of x square plus y square plus z square, and that is a problem because this electronic wave function, which is a function of x and y and z, if you try to separate it out in terms of something like psi e of x multiplied by psi e of y and multiplied by psi e of z, this term in the Schrodinger equation is going to create a problem, because you cannot break it down into something in x multiplied by something into y into something into z. How do you do that with square root of x square plus y square plus z square? So, because of this problematic term, it is not possible to separate out the Hamiltonian into 3 different coordinates. We cannot proceed further even with hydrogen atom if we want to stick to Cartesian coordinates. So, we need to use a new coordinate system. What will this coordinate system be? Well, it is not really new, we are already familiar with it. The coordinate system that we are going to use is spherical polar coordinates. And as we know spherical polar coordinates and Cartesian coordinates are interrelated. So, once we know theta, phi and r, we can actually work out x, y and z, okay, without much hassle. Okay. Z can be worked out by r cos theta, x can be worked out from r sin theta cos phi and so on and so forth. So, if required we can go back to Cartesian coordinates also, but it is easier to formulate the problem in spherical polar coordinates. Why? Because remember what was the problematic part in our formulation. The problematic part was that r in denominator, r is square root of x square plus y square plus z square. So, we said we cannot separate it into something in x, something in y, something in z. But here r itself is a coordinate in spherical polar coordinates, that is the beauty of it. So, since r itself is a coordinate, at least during formulation we do not have to worry about it. Okay? That is point number 1. Point number 2 is it makes perfect sense to formulate this problem in terms of spherical polar coordinates, because as we said a little while ago, it is a central field problem. The electron is attracted to the nucleus, right. So, no matter where it is, if you draw an arrow, so that is the direction in which the attraction is, okay. Central field problem, and central field problems are best handled in terms of spherical polar coordinates. So, this is what we are going to use, and the next step of course then would be to convert the Laplacian into spherical polar coordinates, right. Remember we have already done that when we talked about rigid rotor, okay. At least we pretended to do it. What we said at that time is this here is the kinetic energy operator in spherical coordinates, and we showed you some appendix 2. Remember appendix 2, it was called appendix 2 because originally it was here in this presentation. I lifted it and took it there, okay. So, anyway axiomatically we take the kinetic energy operator in spherical coordinates, multiply it by well, this is Laplacian. So, multiply it by minus h cross square by 2 mu, and to get the Hamiltonian we add minus q z square by r, okay. To get Schrodinger equation for the electronic part in spherical polar coordinates, we make this Hamiltonian in spherical polar coordinates operate on psi e to give us E into psi e, okay. Now, all this is in r, all this is in theta, all this is in phi. What is the next thing to do? The next thing to do is to separate this into 3 equations, one in r, one in theta, one in phi, okay. To do that again I will go through this a little quickly because we have done it many times, but please do it yourself and make sure that everybody is on the same page, okay. To start the separation we multiply with minus 2 mu r square divided by h cross. Why? Because I have this minus h cross square by 2 mu on this side, and here we have r square multiplied by sin theta d phi. So, if we do this, then at least a little bit of cleaning up is there. The first term becomes del del r, this one, del del r multiplied del del r operating on r square del psi e del r. The second term becomes, well, now this r square is gone, 1 by sin theta del del theta operating on sin theta del psi e del theta. What about the third term? We get 1 by sin square theta del 2 del psi e del phi 2. So, in the third term only there is a little bit of mixture of theta and phi. The first term is only in terms of r, second term is only in terms of theta. Last term is only in terms of r, okay. And then what we do is we bring the term in energy to the left hand side as well. So, all this is in r. What does that mean? Before going further, what it means perhaps is that the energy will depend only on r and nothing else. It will not depend on theta and phi. Of course, it is a little premature to say this because we have still not separated the wave function into r theta phi components, but I hope it is not very difficult for you to understand that that is where we will inevitably be headed anyway. Yeah. So, that is interesting, and that takes us back to Rutherford's model. Remember, in Rutherford's model, energy would depend only on the separation, right, what we call the radius of the orbit, or in Bohr's model. In Bohr actually worked out something where expression of energy was there and there was something in 1 by r square, right. So, now it appears that we will reach somewhere similar after all this sophisticated treatment. This is in theta and phi. So, what we have is we have one part in r, one part in theta and phi. So, we can take them to different sides if we write the wave function as capital R, which is a function of r, capital theta, which is a function of theta, capital phi, which is a function of phi, and for the rest of the module we just write it as capital R into capital theta into capital phi. So, you know how to do the separation, I will not say all that, we just do the separation, do the differentiation, I will just do one maybe. When you differentiate with respect to r, capital theta, capital phi are not functions of r, so they come out and you are left with del capital R, del r only. Similarly, these functions come out, and now this is what you get. How do you get the terms together? Just multiply with 1 by capital R, capital theta, capital phi, like what you have done for rigid rotor, and then you get on the left hand side 1 by capital R del R operating on r square del r plus 1 by capital theta into 1 by sin theta del theta operating on sin theta del capital theta del theta plus 1 by capital phi 1 by sin square theta del 2 capital phi del phi 2 plus 2 mu r q z square by h cross square plus 2 mu r square by h cross square E equal to 0. E means electronic energy. Okay. So, just rearrange it a little bit, take everything in r together on one side, take everything in theta and phi on one side, you get upon rearrangement you get this. So, left hand side is entirely in terms of the radius r, so you call it the radial part, right hand side is only in terms of theta and phi angles, so you call it angular part. So, as usual we equate it to a constant beta, because otherwise something that is function of r but not theta phi cannot be equal to something that is function of theta and phi but not r, they have to be constant. So, this beta is a constant that links radial and angular parts. Okay. So, we have been able to separate Schrodinger equation into a radial equation and an angular equation, and the angular equation is familiar to us. We have encountered it when we talked about rigid rotor, remember. So, we know how to separate the angular equation into its component as well. So, that is what we are going to do in the next module, and we are going to recapitulate what we have done in rigid rotor, and we will see how the quantum numbers emerge nicely from using boundary conditions in the subsequent discussion.